Claude Opus 5, Grok 4.5, and GPT-5.6 Terra all claim to be the model built for real work. Only one of them actually backs that up across 5 head-to-head tests, and a running scoreboard settles it. The one that wins the most tests isn't the cheapest, and the cheapest one has a weak spot almost nobody's pointing out. Test 1, Coding Benchmark Performance. Pick the weaker coder and you're re-prompting a broken patch as a deadline creeps closer. The benchmark that matters here is SDOI Bench Verified, which throws real GitHub issues at a model and checks whether its patch passes the existing tests. Claude Opus 5 clears that test at roughly 97%, and independent trackers put Grok 4.5 well behind it at 86.6%. That gap shows up in daily use, not just on a leaderboard. GPT 5.6 Terra doesn't have a directly comparable, verified score in the research here. Its best documented number comes from SWE Bench Pro, a harder version of the same test, where it scores 63.4%, so comparing that straight across would be misleading. Developers shipping code straight from a model's output should care most about this one. Claude Opus 5 wins this test, which puts Opus 5 at 1, Grok 4.5 at 0, and Terra at 0. If you've used all three yourself, drop a comment with which one's actually been the most consistent for you, because real workflows expose things a benchmark can miss. My name is Brian, and I spend most of my week digging through AI products, benchmarks, APIs, and pricing pages to figure out where these tools actually differ. That mattered here too, since all three price these models in noticeably different ways. Test 2, Cost per token. A model that looks cheap can still get expensive fast if it burns through more tokens to finish the same job, and a pricier model can still lose on total cost if you're running it constantly. Grok 4.5 is the cheapest of the three, priced at $2 per million input and $6 per million output. GPT 5.6 Terra sits in the middle at $2 per million input and $12 per million output after a price cut in late July, though it roughly doubles past a short context threshold. That price gap is hard to ignore. That kind of gap matters most at heavy daily volume and a lot less for the occasional prompt. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. Grok 4.5 takes this one, which brings the score to Opus 5 1, Grok 4.5 1, Terra 0. Price only tells you what something costs, not how long you'll sit there waiting on it. Claude Opus 5 is the priciest by far at $5 per million input and $25 per million output, more than 4 times Grok 4.5's output rate, though it charges nothing extra for long context requests. Test 3, Output Speed. Slow output means real waiting time on every long response, and that adds up once you're running a model through dozens of tasks in a row. GPT 5.6 Terra is the clear leader here, generating output somewhere between 107 and 154 tokens per second, depending on its reasoning setting. Claude Opus 5 sits at the other end, generating around 54 to 57 tokens per second, the slowest of the three. Grok 4.5's number is a toss-up across sources. Artificial Analysis measured it at 57 tokens per second, close to Opus 5, while XAI's own claim runs closer to 80, and other trackers report numbers as high as 119, so there's no clean answer here. Terra's speed matters most for long sessions where wait time compounds. GPT 5.6 Terra wins this test, which ties the scoreboard at 1 point each for all three. A tied scoreboard doesn't last once you see how much each model can actually hold in a single request. Stick with me, because the last 4 tests are where this decision actually flips. Test 4. Context and output limits. A smaller context window means splitting up a big codebase, or document by hand, which breaks the exact workflow this kind of viewer relies on every day. Claude Opus 5 runs a 1 million token context window with a standard output cap of 128,000 tokens, stretching to 300,000 on the batch API. GPT-5.6 Terra comes in close behind at roughly 1.1 million tokens of context with the same output cap. Grok 4.5 trails both at 500,000 tokens of context, actually smaller than its own predecessor, Grok 4.3. With Opus 5 or Terra, you can feed close to a full mid-size repository into one call. Grok 4.5 is more likely to hit the ceiling and split files by hand. Claude Opus 5 and GPT-5.6 Terra tie this test, which puts Opus 5 at 2, Grok 4.5 at 1, and Terra at 2. That leaves Opus 5 and Terra dead even, and the last test is where one of them finally pulls ahead. That's a real step back. Final test, deployment and modality. If a model isn't sold through the cloud your company already bills through, that's a procurement problem, not just a preference. Claude Opus 5 is available through the Claude API, AWS Bedrock, Google Vertex AI, and Microsoft Foundry, the widest reach of the three. GPT 5.6 Terra is sold through the OpenAI API and Azure OpenAI, and it already shows up fast in third-party routing tools. Grok 4.5 is only available through the XAI API and the Grok app, with no major cloud marketplace listing found in this research. Enterprise buyers feel this one the most. That gives Claude Opus 5 the win here, putting the final score at Opus 5 3, Grok 4.5 1, Terra 2. All three take text and image input and return text output at the base model level, so modality is basically a tie, and this test comes down to reach instead. That's the narrowest reach of the three. Claude Opus 5 won the coding test and the deployment test. It's the model with the most cloud reach too, but that costs you, since it's also the most expensive of the three and the slowest to generate output. Grok 4.5 undercuts the other two on price by a wide margin. That's real money saved, but it trails on coding accuracy, and its context window actually shrank from the last version instead of growing. GPT 5.6 Terra is the fastest of the three. It also ties Opus 5 on context and output limits, but it doesn't have a headline win on the coding benchmark that matters most to developers. If you want the most reliable model for professional coding work, Claude Opus 5 is your default, because it clears the coding benchmark by the widest margin and reaches the most cloud platforms you might already use. If you're budget conscious or running a model constantly all day, Grok 4.5 is worth choosing, since its per token price comes in well below the other two, as long as you're aware of that smaller context window. If speed matters most to your day-to-day, especially once you're deep into a long back-to-back run of tasks, GPT 5.6 Terra is your lane. If someone gave me zero context and asked which one to start with, I'd choose Claude Opus 5. The decisive reason is that this test set rewards raw accuracy and reach over price or speed, and Opus 5 is the only one of the three that wins on both of those at once. One thing nobody talks about enough: Grok 4.5 actually has a smaller context window than its own previous version. The older model, Grok 4.3, ran a full 1 million tokens, and the new one dropped that down to 500,000. Most people assume a new version means a bigger number across the board, and that assumption is wrong here. If you're budgeting a workflow around what you remember Grok's context window being, an old figure stuck in your head could get you in trouble. If this comparison changed which model you'd actually pick, the next one worth watching is how these same three handle a real multi-file code or refactor, since a benchmark score and a messy repository don't always agree.